Good morning. Well, maybe a good afternoon. I was a little bit hoping that I won't be the only one who will be speaking English this morning, but thank you so much for speaking in Czech. So hopefully, who speaks English in here? Is it fine if I will be speaking English? Awesome. Let me introduce myself first. I'm the principal architect in a company called Natilik. That's my sort of a first job and my day job, which I'm doing over the day. I'm also co-founder of a small service provider called Bulbakovnet in my small hometown. The reason why I'm saying it is I'm in a similar role in both. We're going through the similar transition in the both companies. Natilik is based in London and New York, and we're now going through the transition where we are starting becoming a managed service provider as well. So that obviously brings loads of issues around the telemetry and providing, some sort of the automation to our clients and also to our NOC. Similar journey we're doing now in a Bulbakovnet, where we're sort of like moving from the old school telemetry Snmp wise into the APIs and helping us to automate a little bit more. So that's why we'll be talking today about using streaming telemetry for network automation and monitoring. It's quite a long title. It will be sweet and short, I promise. I won't keep you too much for too long before the lunch. I will be focusing mainly on that monitoring part today, around the gRPC and the real-time telemetry, because it's a huge and it's a very wide topic. So that's why we'll be focusing purely on the monitoring today. So today, these are the main topics, evolution of the network and telemetry. So I will try to show you the link between the evolution of the network and the telemetry. Then I will touch on the OpenConfig, because OpenConfig from the real-time telemetry is a very important part and where the gRPC sits in a modern model-based management. Then I will show you how to implement the gRPC in an easy way and how to start. And also show you a little bit, small, tiny proof of concept to just show how easy it is to configure gRPC and how easy to enable the real-time telemetry in your infrastructure. And then I will touch very briefly on the future and I think where the real-time telemetry is heading in general. So, 30 years ago, we had the legacy network hardware. It was, single box, dedicated function. It was doing exactly what we needed. There was, barely any sort of virtualization on top of those boxes. And therefore, it was very easy to monitor as well. Let's say 15 years ago, we started seeing slight move and slight change in the network landscape, and we started seeing a little bit more of the virtualization, not just on the DC side, but also on the service provider side. And that actually was some sort of a start for all those new things in the networking. Again, not just in the DC, but also service providers. We've seen loads of SDN lately, NFV, which brings loads of challenges in terms of actually understand where these services or where these applications are running. Not even mentioning the containers. They can be basically, popped in and pop out in a seconds. So that brings loads of challenges in terms of the management and the monitoring. And then completely different species, that's the cloud native applications, which are basically built only in a public cloud in mind. You can't run those sort of the applications or services on-prem or in your DCs. So how the evolution of the telemetry is actually linked to those. You probably heard at the beginning, I mentioned the Snmp. That's how we all, know that we should be monitoring our network nowadays. And, most of us is doing it. There has been obviously loads of progress in the last 30 years in terms of the Snmp. We've seen the Snmp version 1, version 2, version 3. There has been some improvements in terms of the security. But in terms of the scalability, there wasn't too much of the progress. We've seen actually a little bit of the opposite, because when you start requesting, pulling the data or pushing the data from the network devices, it could be a little bit painful if you had the large scale network. Also, one of the main challenges of the Snmp is that pull and push sort of the approach, how to getting any sort of the telemetry from the network devices. So that's why we're starting to seeing a NetFlow. NetFlow was some sort of, it was the improvement in terms of it gave us the real-time telemetry from the devices. However, it didn't give us really any sort of the real-time telemetry in terms of the chassis information, about the CPU utilization, memory, etc. It could only give us the information about the flows. IPFix was something which was, and also, in terms of the NetFlow, the issue was the standards. So as you probably know, Cisco has the multiple NetFlow standards. IPFix was trying to fix this with the more of the open standards to deploy this in some other non-Cisco vendors, but it didn't fix really the issue with getting the real-time telemetry from your boxes in terms of the CPU, for instance, and the memory. That's why we're seeing the gRPC suddenly emerge 2 or 3 years ago and trying to fix all these challenges. What gRPC is in 50,000 feet above, it's some sort of like a hybrid between the NetFlow and the Snmp. It has been developed by Google, and now it's developed and owned by the Open Config organization, which obviously brings loads of benefits in terms of how this can be implemented to the other vendors' devices. We're already seeing gRPC being used widely in the containers environment. But we're seeing more and more gRPC also deployed in the SDN networks. From the Cisco perspective, it could be ACI, it could be SDA, and it's sort of the software-defined networks which Cisco is currently pushing. And also the cloud native. So gRPC is starting to being also implemented on some of the AWS services, for instance. So what actually gRPC is? It's the OpenConfig network management protocol. Who knows OpenConfig in here? Okay, I'll give you just a brief, explanation what the OpenConfig is. So you can imagine OpenConfig as some sort of like a cookie cutter. You're sending the API request to the device, and you're expecting some sort of response. The response can be different, not just between the vendors, but it can also be depend between the, for instance, software. So which is running on the box from the same vendor. So for instance, you can get the different answer from the Cisco box, which is running XR and XE, or some old legacy iOS software. This is what OpenConfig is trying to fix. Also, when you, for instance, trying to enable BGP on your network devices, you need to send a different API requests to each device, or even to the device which is from the same vendor with a different software. OpenConfig again is trying to fix this, where basically OpenConfig is the open standard defined by the community, and is defined in the templates how it should be looking when you're enabling the BGP on any of the network devices, and then sort of like a standardize how we are treating the network devices in terms of the from the API perspective. As I mentioned, gRPC is the open source framework. So that obviously, allows all of you to sort of contribute to the OpenConfig. You don't have to be, a programmer to help out. There's plenty of help needed in terms of the documentation, building those templates, lining up the community with the vendors. Great benefit of the gRPC is the HTTP2 as a transport layer. So I will show in the next slides how the transport layer is used on the other network automation or any sort of like a frameworks for the network management protocol, for instance, like a RESTconf or a NetConf. HTTP2 obviously brings loads of benefits in terms of the encryption, bidirectional transactions, all this good stuff. I don't want to go too deep on the HTTP2, but you got a point. And real-time and bidirectional and standardized protocol. So again, loads of benefits. The real-time thing also enables to sort of be first in, first out. So it's pushing the telemetry immediately. It doesn't require some massive buffers, so that saves some costs on the hardware as well. So on this sort of a very busy slide, I was trying to show how the network protocols, network management protocols are sitting, next to each other. So we have the NetConf, RESTconf, and the gRPC. You can see here the difference between the transports. So for the gRPC, it's the HTTP2. I think there is implementation for gRPC. You can use the HTTP2 by default is the HTTP version 1, the one, but I think the preferred one is HTTP2. With the netconf, you can see those SSH and TCP. That's not easy to implement on some of the devices. Again, HTTP2 is much more helpful in here. And then you go with the encoding. So we have a JSON, which is fairly standard for the RESTconf, and also partially for the netconf. But for the gRPC, you can also use the Google protocol buffer, which make it a little bit easier from the programming perspective, a little bit harder from troubleshooting, at least from my experience. And then at the bottom we have the Yang models. So the Yang models you can see in here. I'm using the reference to the OpenConfig. That's how the Yang models can be defined. But it doesn't mean necessarily that the Yang models has to be defined by the OpenConfig. They can be defined by the vendors. But then we're getting into the point which I've mentioned. You can have different Yang models between the different models of the boxes from the same vendor or between the different vendors. So that basically means that if you're programming some sort of automation, you need to replicate this 3 times if you have 3 different boxes. If you're using the OpenConfig, you can basically use the same core for all your Yang models. And at the top we have the SDKs and the application. So you can imagine this one as some sort of your core, and the core can have the northbound APIs and the southbound APIs. The northbound APIs helps you with the communication with the applications and how you sort of doing the automation on top of your network. So gRPC has multiple models and modules. In here we have the GNMI, GNOE, and gRB. The GNMI is the most common one and most frequent one nowadays. Is the gRPC network management interface. Basically, what it does, it enables you to establish the gRPC between your server, where you're running the gRPC collector, and the endpoint, which can be the client, anything, NFV application, it can be network device, anything really you want to run. Then we have a GNOE. GNOE is more of like a provisioning thing. So GNOE can be, for instance, since we running GNMI and a gRPC over the encryption, over the encrypted channel, we need some sort of certificates on those clients, on those endpoints. That's where we're using a GNOE. GNOE is basically like pushing the certificate towards the endpoint and deploying the certificate on the endpoint, so we can then have the encryption through the gRPC via the GNMI interface. And then we have a gRB. Not well defined yet. I know that Google is working on this one to sort of extend it and define it a little bit better. You can see is the gRPC routing information based interface. Basically, what it means is, if you're familiar with the terms like segmented routing, etc., through this interface, Google will be trying to sort of manipulate with the routing on the clients. From the implementation perspective, what is currently available on the network devices, it's usually GNMI. Well, usually most of the devices I know, most of the vendors, they support GNMI. Some of the software has a little bit limited sort of availability from the feature set, but most of it GNMI supported. GNOE is still at the very beginning. I've seen some beta from Cisco where GNOE has been supported, but nothing in production. And gRB, again, it's not even defined properly yet. So if you look at the code, I don't want to bore you too much with the code in here, but basically this is how it's, if you look at the source code, at the libraries which are defining GNMI, this is a one function, which is basically providing the gRPC capabilities. So you're starting this service to get all the capabilities which are available on the client side. And then you have the gRPC subscribe. So as I said, bidirectional. So having the bidirectional channel, you need to subscribe to something. So that's why you have this function where you subscribe to the client. All of this available in these libraries, so you can program nicely in the Golang, Python, or C++. And then these ones are, there is some sort of a parallel from the Snmp, so you can have the 2 types of the responses and requests. One is get and one is set. This is basically like a pull, and this is basically like a push in the Snmp world. There are still some use cases, for doing so, but you should really, prefer more of having the channel set up with the client and just receiving the real-time telemetry. That brings, lots of benefits if you're having this channel, because, for instance, what you can define in the gRPC is that you're receiving some sort of events or notifications from the endpoint, from the device, if there is any change. So you don't really need to do what you're doing, for instance, in Snmp. You're like pulling the data. You're just basically on repeat, asking the endpoint if the interface is up, and you're just like doing it on a repeat, because for some reason you can't monitor the Snmp traps, or Snmp traps are not supported on that particular interface on the device. So you're basically only triggering that sending of the events from the endpoints only if the event happens, and then it sends it through the HTTP2 channel. So there's I know it can be, a little bit overwhelming. It's quite new. gRPC is not widely known yet. So how to start with the gRPC? You can obviously go a little bit hardcore, and you can start, programming with those libraries which are available on the GitHub. Or you can go a little bit easier at the beginning, and you can download the YDK, which is some sort of like a pre-built environment, including all the necessary libraries from those in single container, and you can basically use that container for getting those requests and using all the libraries you need in your applications. Some of you probably know Telegraph, so it's basically some sort of a client which can help you out to translate the values which you're receiving from some of your endpoints. Telegraph supports at this point GNMI for Juniper. It doesn't support the GNMI for Cisco, but I've heard something that the features will be added very soon for that. So I will show you, very small proof of concept, just to give you, just to put things together into a little bit of the perspective, because I was just talking about the theory by now. So let's put all these things together. So we have a router in here. I choose to use the XRV 9000 because it's easy to deploy. It has been running very nicely also with the virtual Juniper with the MX. But in this proof of concept, I've used this one. Then for the pipeline, I'm using the GNMI pipeline, which you can download from the GitHub. So basically, what the GNMI is doing is translating. It's basically building that channel between those two, getting all the data from the router, and then translate it into whatever is needed. If we would have more time, I would show you the proof of concept with a Kafka. We have it in our lab, but I'm not going to show it in here because explaining how it works with Kafka is a little bit complicated. But what I will show you is this integration with a database. So I'm using Influx Db because for these kind of things, Influx Db is probably the best option. But that's what I will show you in the next few slides. So this is how the configuration looks like. Can you see it, guys? Is it okay? Isn't it too small? In here, the most important bit is this one on the router. So literally, these 3 lines will enable the real-time telemetry on the XRV. If you are not doing a proof of concept, you're doing production, it's actually 2 lines because I've disabled TLS, which I wouldn't recommend for the production. But this is what I did for the proof of concept. Then we have the configuration of the pipeline, which is doing all that sort of the transition, between the router and translating really the metrics which is receiving from the router into the Influx Db format. And then we have the Influx Db. So you can see in here, I've used like a simple request to the database to just show us some free physical memory. So this is obviously the time value, and this is the value. So every time it's changing, and just for the record, this is what I've set up. It's doing every 10 seconds. That's hence you can see here uptime at 10, which means every 10 seconds do so. But what you can also do is it will start sending the metrics every time it's changed, which is probably not what you want to do in terms of the memory, because memory is changing all the time. So it will get overloaded pretty quickly. Okay, so I've tried to zoom it in to help you out a little bit. So this is what I was talking about, those 3 lines. I've done the show gRPC streams. So it shows, that we have these streaming gRPCs established, 3 sessions. what type of user, what's the duration. So you can see in here, about the 10 minutes established tunnel. You can also identify it by ID and when it was created. So it's quite helpful for the troubleshooting. And in here, that's one of the benefits of the gRPC as well. So imagine you have the thousands of devices, hundreds of thousands, and you don't want to really define all the Snmp configuration. You don't want to define all the Snmp traps which you want to receive, etc. What you want to do is on a single collector, you want to define what will be monitored. That's what we define in here. So we've defined memory summary, system monitoring, CPU utilization. We also we're requesting some information about the interfaces and the uptime, and that's all you need to do. Then on the endpoint, you just do this, and that's all you have to really define on the endpoint. So then suddenly you start receiving all those metrics, all these telemetry into the Influx Db, and then into the Kafka, and then afterwards it's up to you what you want to do with those data. This is, I was trying to zoom it in a little bit. This is what we're doing, for instance, with our stuff. So we're using Grafana for visualizing those details from the Influx DB. But you can do the same thing with anything, any other monitoring you have. So how it looks with the implementation. I mentioned many times Cisco. Cisco is doing pretty well in some versions of the software. So XR, it's doing okay. I think gRPC and GNMI has been integrated or implemented like a year ago. So it's very stable. We have some good experience with the XRs. NXOS gRPC, very good. It doesn't support the GNMI yet. So what basically you won't be able to do if the GNMI is not supported is that sort of a dynamic in here. So you can't really expect when the device will be understanding this. You will have to define these on the endpoint, and I had it in here. So you can see the sensor path. This is what you will have to define if the device doesn't support the GNMI yet. So with the NXOS, a little bit tricky, but doing okay. XE, still at the very beginning. gRPC, it supported GNMI, very limited from my experience. gRPC is nicely integrated into wireless. So for instance, Cisco is already using it for some wireless real-time telemetry into the DNA center. And then we have obviously Arista and UNOS, strong as usual. Haven't had really any issues with that. And obviously Kubernetes. The gRPC is now very nicely integrated in there. So where I think before I will wrap up, this is sort of what I think the gRPC means for the future. When we're talking about the Kubernetes, which basically cover all those NFVs, containers, cloud native applications. We're talking about the Cisco physical hardware. We're talking about the some virtualized software like the XRV 9000. We're seeing that we're sort of streamlining how we're going to be monitoring the services in the future, and that's why I think the gRPC is the right answer to it. It's open software. It's using the open config YAML models as well, so can be very nicely integrated into any sort of environment by any vendor. It's just it just needs some time, and I think we're getting into the point where it's ready for the production on most of the software. I think gRPC will help to disaggregate the network functions, and it's actually we can see similar stuff in the wireless. When I mentioned when Cisco is using gRPC for the wireless, we can see that Cisco is starting to separate the management significantly from the APs and from the controllers. So everything is now becoming available in a separate management tool, which in Cisco case is a DNA center, which wasn't possible without the real-time telemetry. You just need to have some sort of a real-time response from your network to be able to automate. And that actually, confirmed that the third point, a more responsive network allows greater adoption of the automation. So that was our main priority when we were starting to deploying gRPC for our clients in Natilik, either it was in Europe or US, or for the local provider, because that brought us that missing bit where we had a direct response from the network. If we change something or has been changed something automatically, we were able to get the response from the network immediately. And that's pretty much all for me. These are my details if you want to stay in touch. Thank you for your time.
Thank you very much, Matthias. Are there any questions, either here or remotely?
Yeah, that's the only language I don't know.
Okay, so the question is, I can see that you have a Czech name. Why do you speak English here?
Because I'm working English. And it's tricky, actually. Yeah, it's I was a little bit worried to speak in Czech because like I'm presenting these slides usually in English. And if I switch in Czech, it's
absolutely not. I know this feeling. Yeah,
sometimes it hurts.
I agree. So the next one.
So what were those huge drops in the free memory on the Grafana graphs? I suspect these were because I was using our lab ESX host, and there was someone in the background playing with something. So that's why I think there have been some memory drops on the virtual machine.
Okay, any other questions, perhaps in Korean or some other language? No, excellent. So that's the end of the session. Thank you very much. I apologize for being a bad chair, doing such a lousy job because we are a little bit delayed. But anyway, now we have just lunch, which will be provided upstairs, and we will meet here exactly 2:00 p.m. So see you in about an hour. Thank you very much.